welcome to this first tool in action of the day. Thank you for being here after the break. Looks like this room turned out to be a performance-heavy room. My talk is again going to talk about performance, but maybe in a slightly different way, and I hope you'll get learnings that you can apply as of tomorrow at the job, even if you're not using Gradle. So don't let ephemeral CI kill your developer productivity. My name is Louis Jacomet. I'm an engineer on the Gradle build tool team. I've been also in the DevOps organization for a while, worked on caching products before that, and yeah, I guess the only thing I'm usually saying is that I'm an almost 50-year-old engineer that kind of messed up and ends up doing management once in a while. The Gradle build tool, just to give you a bit of context of why I can actually come here. So it's an open source tool, JVM-based, you've got a Kotlin and Groovy DSLs. We have 30 plus millions download a month. We'll go back to that number at some point. And an extensive plugin ecosystem. Now, the reason I can be present at conference is because there is also a commercial product behind that, Develocity, which actually allows you to aggregate build data, not only from Gradle, but also from Maven, Bazel, and SBT. And with that tool, one of the most useful part you get is what we call build scans, which is a permanent record and view of a build that you ran and which allows you to extract information out of that or share problems that you want to debug with colleagues. We'll use build scans when I illustrate the talk, but the whole point is not to talk about build scans. So, what are we going to talk about today? Well, first of all, I'm going to explain my problem statement, right, the title of the talk. Then we're going to look at what it means in terms of a build profile, specifically for Gradle, but I'll highlight the parts that are somewhat common with Maven. And then what are the possible actions we can take with regards to making your build performant in the context of our problem statement. So the problem statement. On one hand side, I'm putting the performance of the build tool, so the execution of a build, how fast can it be? And the other one is this trend of using ephemeral environments, which means environments with some specific characteristics that if you don't pay attention, will have dire consequences on that performance aspect. So first of all, how do I equate developer productivity and build performance? Well, because it's one aspect of developer productivity. If you can get results of your changes faster, then you can iterate faster, you can react to whatever happened, whether it's a success or a failure, and move on. And one thing that we hear often is a fast build. But what is a fast build? And so at Gradle, we don't think fast builds are the goal. We think that the goal is to actually have a build which is as fast as possible. If you can shave off a few seconds, amazing. If you can shave off a couple minutes of an hour-long build, isn't that even better? And if you can manage to get your build down to less than 10 seconds, who wouldn't like that? So let's do a small show of hands. Who thinks that a 4 hours build is fast? Yay, no one. That's really a good start. 1 hour? Is that fast?
Depends.
Exactly. Depends is the real quick answer. But so let's say running all your tests, an hour. Is that fast? Half an hour? Yeah, see a couple hands already showing up. 10 minutes? Yeah, more hands. 2 minutes? Yeah, starting to get good. 30 seconds? Yay. Okay, so, and we can see already that just when I ask the question, it's a tough one to answer. So we'll get back to that performance aspect because, of course, it really depends what exactly are we running, but we're going to see that the whole point is to be as fast as possible versus being fast. When you look at the Gradle build tool documentation on build performance and improving the performance of your build, you'll see these high-level sections that you can look at. So we'll see stuff like parallel execution, having a daemon, incremental build, build cache, increasing the heap size, optimizing dependency resolution. We have like a number of things that we can do in order to speed up a build. What does it mean, though, to speed up the build in the context of an ephemeral environment? Well, this is definitely an industry trend, right? We see more and more that either for testing or for the whole CI pipeline, we use environments that have two characteristics. They're isolated, meaning they run only once, one set of tests, one build, and then after that they kind of tend to disappear. And they're short-lived, like the disappearing part. Now, the fact that they're isolated means that we're trying to escape the state problem. But it doesn't mean that we should have no state at all. It just means that we should have a very well-known state and then not inherit any unwanted artifacts from the execution we ran on that environment. And short-lived is effectively a way that you don't have to clean up things, you don't care about open file handles, you don't care about processes that don't want to die. All of that is kind of abstracted away because you actually kill the whole environment. So if we look at the combination of the performance element of a Gradle build and running them in such an environment, we can see that parallel execution, this really scales up with the size of the machine. So yeah, sure, that's an advice that you should apply. The Gradle daemon. Well, the whole point of the Gradle daemon is to have a hot JVM process that's going to run multiple builds. So by definition, unless your step in that environment has by itself multiple builds, that's not necessarily a win. Configuration cache, I'll go into more details what the configuration cache is exactly, but once again, we're caching things. It depends, right? Do we still have the cache accessible on the next execution? Incrementality, that's definitely a no-go. The whole point is to run a second iteration with incremental changes. If the environment is gone in between, you won't get any benefit. The build cache, let's assume we have the remote build cache that gives us what we expect. You've cached some results of computation, you can get them back even if they're not local to the machine. Build for specific developer workflows, you can apply that to CI. You have a specific configuration which optimizes the tasks that need to be run, skips the ones that are unrelated. So yes, of course you can do that. Heap size, we are back to the parallel problem. Size of the machine, as much as you have. If it helps, it's good. Optimizing the configuration time, I mean, you should always do that. It means your build will be faster in any context because it does less work or it does exactly the work it needs to do, no more, no less. Optimizing dependency resolution, I mean, it's a bit hidden from the title, but when you look through that chapter, it's mostly about making sure that all your downloads are properly cached and available on the subsequent execution. I mean, if we talk again about ephemeral environments, just applying the basic recipes will not work. And then optimizing specific projects like Java or Android ones, that really depends on what kind of optimization we're talking about. And so we'll see that there are things you can do depending on that environment. So if I look at what we call the key Gradle build tool performance elements from a slightly higher level, we've got one family of improvements, caches, which the dependency cache is one of them, the task cache is another one. We'll see that build script compilation cache is in there as well. So Gradle uses a lot of caching. We have the incrementality with the whole execution history of Gradle, with the ability to fingerprint the class path so that we know what needs to be recompiled when there is an incremental change to your Java code or Kotlin code or Groovy code. And then we have the whole parallelism aspect, where we try to execute not only tasks in parallel, but also potentially your tests. And even if you have the velocity, you can like distribute tests and things like that. So in that environment, once again, the caches, well, will have to be smart. The incrementality, we're pretty much out of luck. Again, we'll see that there are potentially ways around that. And the parallelism, definitely. Like, if something can run in parallel and you have large enough machines, then of course it's going to run faster. So, in order to illustrate that, let's look at the build profile of a Gradle invocation, or the profile of a Gradle invocation. At the high level, there are three phases. You will hear the Gradle configuration and the Gradle execution as the biggest phase in the documentation. So configuration is when Gradle builds the model of your execution and knows what to do, and then the execution is effectively compiling the code, running the tests, running the static analysis, creating the archives of the products, and all of that, and potentially publishing. But there's also an important piece, which is the Gradle startup. And if we look at the startup, well, it's a JVM tool, so we need to start up a JVM, right? But if you're in a completely cold environment, the next thing that happens, thanks to the Gradle daemon, is that you end up downloading a full distribution. Once the distribution has been downloaded, we have to prime it for use. So Gradle, in order to reduce the size of the distribution, has a couple jars that are generated at runtime. And so this happens in that green bar. So none of the bars are at scale, because again, scale could be very different depending on the build profile you have. And then finally, we will start the daemon. If we move to the configuration phase, we'll see that we have a set of plugin dependencies that needs to be downloaded and resolved in order to apply the different plugins. Once we've gotten all of these dependencies, we can finally compile the build logic, effectively create the model of the build, and then build a task graph, meaning what do we need to execute based on what the user requested. And once again, here the bars are not at scale because it could very much depend, right? You could have a huge build that has tons of dependencies but very small scripts, or the opposite. So that's really, really specific to the build. And then finally, for our execution phase, we'll have again to resolve dependencies. These times we're talking about your application dependencies, whether they're production or test dependencies. That's the things we need in order to compile your code or run your tests. We'll do quite some work, which I labeled inputs fingerprinting, to figure out what would need to be done if a subsequent invocation had a set of minimal changes. And then finally, we would run the execution of the tasks. So here again, bars not at scale. The inputs fingerprinting is definitely not designed to take a third of the time. It's more like it should be non-measurable, but it still is an important aspect of what happens during a build execution. Then what can we do with all of that? Well, the first thing we can do is realize that this talk is about performance, and so everything I say needs to be taken with a grain of salt and needs to be confirmed in your specific environment. So measure, do some change, measure again, and compare. If you don't do that, and you apply blindly some of the recipes I'm going to give here, you may actually make your build slower because you may be in a weird environment where the network is so fast that copying stuff on the disk makes no sense. Or the disk is so slow that you should actually tweak your build differently because you have to account for that reality in your specific environment. So this is really important, and it's funny because we discussed with the previous speakers of this room today, and they were asking me whether I had such a slide in the presentation. And so the answer was yes, I do have one. Performance means measure, change, measure, compare. So what can we do for the Gradle startup? Well, first of all, Gradle comes with two distributions. One is the bin one, the other one is the all one. The all one contains all of the documentation. You don't need that. You need documentation when you're a developer inside the IDE, and guess what? The IDE will download the documentation as part of the process of syncing the project, which means on CI, definitely downloading the all distribution is a waste of bandwidth. Now, instead of downloading it, you could make sure that the Gradle distribution is actually part of the Docker image, of the AWS AMI, like any kind of setup you use to prime these ephemeral environments, they could have the Gradle distribution as an element in them. Or you could make sure that instead of downloading it from a Gradle server, you could download it from a local server in your organization, which could be in the same cloud, have high bandwidth. And so here again, we see like you have options, right? And it depends on the setup. Or finally, you could have a system, which is what we use on the GitHub action, where you actually save and restore specific folders under the Gradle user home. That's what the GUH stands for, Gradle user home. Because if you copy over the wrapper dists, then you know that you'll have available for the next execution the Gradle distribution required by the given project. Then, as I said, that Gradle distribution, the first time it runs, needs to generate jars. So either, again, as part of the process of building the image, you run it once, like you do a Gradle help on an empty folder, it will generate the files and then tell you, oh, there is no build here. But at least after that, it's part of the image and we don't have to generate them anymore. Or again, save and restore the specific cache folders that contains these jars, and so you'll find them under the Gradle user home, caches, version being the Gradle version, generated Gradle jars. This is literally 10 seconds, usually, even on an M1 or M2 Mac. So we're talking about saving 10 seconds. I mean, when we were back into the 1 hour build, is it long? Okay, maybe it's not that much. But if we were talking about, can we have a 30-second or less build, 10 seconds is a third of that time. So that can have a negative impact on everything you're doing. Then we had the second phase, right? The optimization of the Gradle configuration. For that, we can use the dependency cache. So Gradle has a smart dependency cache, similar to the Maven local repository, right? These are caches for the pre-downloaded dependencies. So this specific feature applies to Maven as well. You can save and restore caches modules too, which is the equivalent of the M2 repository. Or there is a read-only cache feature. And so, for example, what you can do with that feature is if you know that a number of containers are going to run on the same physical machine, you could have this read-only dependency cache available on the machine, mount it as an available resource in your Docker containers. They could all read from that, not try to write to it, and you would get the benefit of not having to re-download dependencies. Then another thing that was important was the compiling of the build logic. And so here again, we can leverage caching with the Gradle remote build cache. So that's not a cache of dependencies. That's really a cache of, in this case, the compilation result of your build scripts. And so if you turn on remote caching and you have a remote cache node, whenever Gradle compiles your build scripts, the result of that compilation will be uploaded with a key. And when a subsequent execution of Gradle has the same input key, if the entry is available in the cache, instead of calling a compiler, we bring back the results. When you look at languages like Kotlin, for the Kotlin DSL, reusing compilation result can really be a time saver because there is a price to pay for starting up and running Kotlin compilation. And so remote build cache is one way, but still it means you have to pay a network price. So depending on your setup, that may be too costly. So you can instead save and restore, again, a number of folders, the caches version Kotlin DSL, caches version scripts, or caches jars 9. That 9 is actually a version number. So it might be that in a future version of Gradle, it's called jars 10. But so this would give you effectively a series of caches that represent the results of building your build logic. For the Gradle execution, same kind of recipes. I mean, this is not rocket science, honestly, but this could save you like CPU times, money in your environment. So this is really the essence of my message. So once again, for the Gradle execution, the exact same dependency cache is actually shared by the build logic dependency cache and the project dependency cache, because if we downloaded Guava once, whether for build logic or production code, why do we need to download it a second time? Like it's the same file. Then you've got the task execution cache. So similarly to the specific compilation cache I mentioned, this is a more generic cache for any kind of task output. So whether it's a core Gradle task or a plugin provided or a self-written task in your custom build logic, you can make your task cacheable. And so it means that Gradle will identify a key based on the input of the task and cache the resulting output. And if you have a subsequent execution where the inputs didn't change, we can reuse the results of your task. Things that we typically don't cache are things like archiving, because archiving is usually cheap. Once again, let's assume your CI environment has some weird disk setup, which is really slow. Maybe turning on caching for this task makes sense because your download speed is faster than re-archiving locally. If you don't measure, you'll never know. So remote build cache again for the task execution cache, or use the caches build cache 1. Again, that one is a version, so it might go up to 2 or further depending on Gradle versions. And for Android, you also want to cache the transforms folder. Android use a lot a Gradle build tool feature, which is called artifact transform, which allows them to effectively take an AAR, which is an Android application, and then extract the different bits and pieces for having different build logic be tailored to those. Another one is the provision toolchains cache. So toolchains in Gradle is a feature that allows your build to actually compile and execute your test with a JDK version that is specified by the build configuration and is independent of the Java version that runs the build itself. So Gradle today does not support Java 21. That's not a problem. The next version will allow you to compile and execute Java 21 code and tests, but you still won't be able to run Gradle itself on Java 21. So we broke that single JVM, and you can actually have more than one. Funnily enough, we developed recently, I think it was Gradle 7x, a plugin system. No, it was stable in 8, yeah. A plugin system so that Gradle can auto-download a missing JDK because you don't have it on your machine. And the plugin that Gradle released leverages the Fuje discovery API from the Fuje community platform. It went down a couple times these past few weeks. And so they finally looked in, like, not only did they put it back up, but they also looked into why it went down. It's us. It's the Gradle plugin. The Gradle plugin brought it down. Why? Because this runs in your GitHub Actions on CI and other places, and instead of reusing a JDK that's baked in your image, will download these hundreds of megs every time you run something. And that means you pay the bandwidth for that, you pay the time it takes to do it, and also we actually kill the nice discovery API, which was mainly designed for helping folks that need a JDK locally. They can ask from it and get it easily, but never to be used at scale. And if you think about it, when I mentioned these 30 million downloads of Gradle distributions, and I said, please do have the distribution in your image, it's because it's the same reason. While I would love to be able to say we have 30 million unique users a month, that's not the reality of things. We have tons of machines in that amount of downloads. So, any questions at that point? Okay, then let me make a fool of myself a little bit. Let's look at what this means in practice. I have a Gradle plugin called the Logging Capabilities plugin, which effectively allows you to fail your build if you have incompatible logging dependencies on your class path, instead of having to wait until runtime to discover that your logging setup is broken. And I've been using GitHub Actions for a while in order to build that. So I had a Gradle build action, a publish action, and a wrapper validation action. And I thought, yeah, why don't I use my plugin as a way to illustrate what I just discussed today? And so what I did was I created an action, which is basic build. And so that checks out the project, set up Java. I'm using Java 8, Tamarind. And then, no, wait. I need the basic one, not the basic build, my bad. So check out, set up Java, Java 8, and then I run my build, right? Oh, is that better? Yeah. Thanks. So, and then I run that, right? And so if I go into my basic execution, we can see that I run it a couple times. It's always the same commit, and it's always taking a bit more than 3 minutes. So I'm effectively doing a number of things, always the same, always taking 3 minutes. Here, what I'm running in build is I'm running all my functional tests, building the code, and that's pretty much it. So we have a Gradle GitHub action. And what the GitHub action does is it applies effectively a number of the optimizations I mentioned in my talk. So it will be smart about the caching. It will cache a number of things so that the next execution is faster. And so the only thing that changes is I've got that setup of the Gradle build action, which will only cache if we're building from main. So we don't want to pollute the build cache with pull requests because they may contain invalid code, or they may contain problem, or they may actually contain, specifically designed, crafted code to extract or poison the cache. So we just do that from main. And then let's look at what it meant, right? So I run it a couple times. The first time takes 3 minutes. Yep, sure, that makes sense. Second time, 3 minutes. Wait, that doesn't make sense. I was like, why did that not work? Because I should have at least get some caching. Well, the thing was, the setup of the action was still only using the cache if you were building on master, but my repo uses main for a while already, the change of the main branch name. So I already realized, oops, wrong setup, had to change the configuration of the GitHub action and rerun again. So that means we get another run, right? That's supposed to prime the cache, and effectively, if you open that run, it tells you caching for Gradle build action was enabled, expense for details. Okay, cool. So at least I had my caching. So now that I have my caching, next build should be faster, right? 2 minutes, 24 seconds. Wait a sec, that makes no sense. I was expecting a much, much bigger impact of the caching. Well, it turns out that I work on Gradle, so I've got lots of options of Gradle that are actually configured only in my Gradle user home, like caching and parallel. So what was missing was this file, my Gradle properties, to say, hey, this project should really use the caching and the parallel mode, because it will benefit developers locally, and when it runs on CI, it means the caching will happen. And effectively, you can see that as soon as I turn that on, of course, the next build, 2 minutes, 22 seconds, because I still need to prime the cache, right? Because my build was not cacheable before, or at least was not using the caching. And then finally, I go to that 31 seconds. So this means that I went from a 3-minute build to a 31-second build. Of course, I'm rebuilding the exact same thing, so it's not completely fair. Like, I'm getting the maximum benefits of the cache. But you can see already that this is a 6 times improvement. And it's an open source project. It doesn't see tons of builds. But if you do something like that in your own project, and you have thousands of builds a week, with 52 weeks a year, this can really start counting, whether in terms exactly in processing resources, in money, in being greener, which I guess is good, So really what I wanted to show with that example is the kind of benefit you can get. And now what will happen is that if someone opens up a PR, does a small change, well, everything that doesn't change doesn't have to run. Only what is changed will effectively be run. And so they won't get to the 30-second execution, but they will get maybe between 30 seconds and 3 minutes, depending on the size of the change. So if I go back to the presentation, what does that mean? Well, it means that if you're smart, spend the time and do the measurement, you can get quite a number of things for free, even in your ephemeral CI environment, like no distribution download anymore, no distribution first use cost, no plugin dependency resolution. We will still need to compute a dependency graph, but that will be based on already downloaded binaries. No more build logic compilation. If you don't change the build logic, that step will be completely skipped thanks to the caching. And similarly, no more dependency resolution, which means, if you think about it, you're left with the fundamentals. We have to start a JVM. You made the decision for the ephemeral environment, so you don't get the big benefits of the daemon, so you'll have to wait for a daemon to start. We will build the model and the task graph. Then we will run the execution. And so, for example, the inputs fingerprinting is interesting because if your disk is really, really bad in CI, you may actually benefit from explicitly disabling incremental compilation in Gradle, because then we will not try to build an incremental compilation profile. That's what I had for you today. Thank you. I think we've got a minute for questions, so if there is one or two. Yep. So the question is there an equivalent for GitLab from the GitHub action we have with Gradle? No, not at this stage. I know it's been discussed. The one thing I can say is that the GitHub action for Gradle has extensive documentation about what to cache, how we compute the cache keys to be smart, in order to not grow the cache too much and things like that. So if you have an interest, that could be a nice side project. Otherwise, it may happen at some point, but I can't promise anything there. Any other question? So the question is it safe to reload or use a cache across multiple containers at the same time? It depends. Like the dependency cache read-only that I explained, yes, that's designed for that. Conceptually, a Gradle user home should be used by a single Gradle process unless they can communicate between each other, which is usually not the case when their container is isolated. Thanks, time's up. Enjoy the rest of the conference, and we have a booth, so if you want t-shirts or having a deeper conversation, come see us as of tomorrow. Bye-bye.